Alright, in this video I'm going to go over how to manipulate the raw data once it's been collected and turn it into a nonlinear graph so that we can determine the relationship. Okay, so we've already written up this first part where we've prepared our documents, so we've got a brief description of the independent, dependent, and control variables, and we now want to kind of manipulate our raw data. So we'll go to Excel where we have our raw data set up in a sheet like this. And we've got our masses that we've chosen. We've got our 3 different times for each mass. And the first thing we want to do is include our uncertainties. And we were told in the sheet in this case that the uncertainty in the masses was about 4%. In most experiments you'd need to establish or estimate what the uncertainty is going to be yourself. So 4% is equal to 0.04 times our value, so 4% of our mass. And then we'll autocomplete that by dragging down on this little green box. And now we have the uncertainties in each one. Uncertainties should always be expressed to one significant figure, so these ones here will just reduce to one significant figure like so. And then these values here should all have the same number of decimal places as our uncertainty, so we'll increase those 3, and these 3 are already okay. 2 decimal places, same as the uncertainty. The next step is to compute the averages in our 3 values. So to do that we just write equals and type the word average, and open a bracket and select the 3 cells that we want to average. Close the bracket and hit enter. And then again we can autocomplete that to work it out for each row. And those are our averages. We've got one value here that has only 1 decimal place. We can make them all uniform by just doing that, and we should really have 2 decimal places because we measured with a stopwatch to the nearest hundredth of a second. The uncertainty in the average is going to be half of the range of our 3 values, and we can calculate that in Excel like this. Equals, open bracket, and then max, and then we choose the 3 that we want to find the maximum value for. We subtract from that the minimum value of the 3. And that's now the range, and we want to divide that by 2. So what this is going to do is pick the biggest of these 3 values, subtract the smallest of these 3 values, and then divide by 2, which is a method of estimating the uncertainty when we've collected multiple trials and averaged. And we can autocomplete that for each row, like so. Okay, so now we have our uncertainties. However, they're not all to one significant figure. We really want them to one significant figure, so we'll just reduce the ones that are not, like this. Now they're all one significant figure, and we want these to match, so that one there needs to be reduced by 1, oops, like that, and like that, and now they're all good. But this is 10 oscillations, and we want 1, so for period, in seconds, we'll just go, this is going to be equal to the average value over 10. We can autocomplete that. And then the uncertainty in period, so let's just merge those 2. Uncertainty in period. And we want to wrap the text so that fits. Okay, uncertainty in period is going to be equal to the uncertainty in the 10 divided by 10. Cool. And now we have, now we have our uncertainties as well. Just scroll back. And then we just want to get the significant figures right here as well. So uncertainties, remember, need to have just 1 significant figure. There we go. And these ones need to match. So, this one, this one, this one, and this one. I want to have to 3 significant figures, like so, like so. This one, and this one. To make selection of multiple cells and highlight them all, you just hold down Control while you click. Okay, so 2 decimal places for those. Yep. Okay, so now we have all of our raw data here. I'm going to copy that into my Google Doc so that I have that there, like so. And then I want to also just give that, why did that copy in this format? There we go. And then highlight everything and add a border, which we can do here. Cool. Okay, so now all of our data is included in our report. The next step is to draw a nonlinear graph using the raw data. So I'm just going to zoom out a little bit so we can see the raw data that we're interested in. So we want to plot a graph of mass against period. So to do that, we can just highlight the data in question, like so, highlight that, and then hold down Control and highlight this. So we're going to get a graph of period versus mass. Click Insert, choose a scatter chart, and there's our data. Okay, there are a few elements missing here, so we're just going to add those. We're going to add axis titles. We're going to add a trend line. Anything else we need here? That's basically it. So, in fact, actually, the trend line I'm just going to format straight away. We don't want a linear trend line for this because it's non-linear data. If we choose a power one, that looks reasonably good. And we can even extend that backwards all the way to the start, so we get a nice curve. And the lowest mass value that we had was 100 grams, so I'm going to forecast backwards by 100. There we go. Okay, and now there are just a few editing things that we need to do. Like we need to change this to say mass in kilograms, and this one here needs to say period in seconds, and this is period versus mass for mass on a spring. And then one last little thing, which is a picky thing, but if we go here to series 1 and click on marker, we can change our points to crosses. Okay, that graph now looks like a good nonlinear graph for our data, and we can add that in here. And we can say this looks like a square root relationship, so I will square root the mass to transform the graph. Okay, so that's basically all we need to do with the raw data. In the next video, I'll go over how to transform the data, now that we've established that it needs to be square rooted, and plot the linearized graph. Okay,